Greetings and welcome to a video tutorial on files, the most exciting of topics. Now, this is going to be language agnostic. I'm going to be talking about the general idea and theories behind file manipulation rather than any one language's specific way of dealing with it. So it doesn't matter whether you're working with C, C++, C#, Java, Boo, yes, that's a language. This will still apply if the language allows you to manipulate files, which, yeah, most of them do. Also, I apologize for the horrifically bad backlighting, but if I point the camera that way, you can see most of my house, and I will be murdered by my wife if I show you that. Okay, let's get into it. I'm the program. I am a peanut butter and jelly sandwich making program because that is my favorite thing to use for these real-life demonstrations. I need to make peanut butter and jelly sandwiches. Now, some of the stuff I have on here can sort of represent variables that I might have to assist me in the process. So I have a plate for putting the sandwich on. I've got spoon and knife for getting materials out or accessing my data. I have a napkin because I'm not a savage. And an unhealthy amount of caffeine that has nothing to do with making sandwiches. But you'll notice something is missing here. The materials to actually make a sandwich with. There's no bread, there's no peanut butter, no jelly. Kind of hard to make a sandwich without those things. And this is demonstrating the idea of file paths. Most of the time, your file is not going to be in the exact same path or the exact same directory as your data. You can sort of think of me as currently being in the path of house, dining room, table. That is my current path. But the path for my jelly is house, kitchen, refrigerator, and the path for my bread and peanut butter is house, kitchen, cabinet. So everything is in different paths. So in order to access that data, in order to access the materials I need to make a sandwich, I have to know where those things are located. Now, in order to not drive myself crazy constantly getting up and having to walk over and get things, I am going to bring the materials here. Keep in mind that most of the time your data and your executable will not literally be in the same directory. It might be. It's more common for it to be on a subdirectory. For example, maybe I could use my chair off to the side here to represent my data storage, and so maybe I'll have my data over there. But again, I don't want to be making peanut butter and jelly sandwiches off of my kitchen chairs. Again, reference previous murder comment. All right, so I have my data, and my data is in the same directory as me, so I don't need any relative path information when I go to open my files. What's next? Well, I have to pay attention to file formats. Get right out of the way here for a moment, which is why I've got multiple containers here of peanut butter and jelly. For example, for this particular file, if I open it up, there's no top. I can just open the file and access the data directly. All well and good. But this file has a header. There's additional stuff here that I have to deal with before I can get to the actual data that I'm concerned about, the peanut butter. It's not uncommon for files to have like a little header section telling you about things before you get to the actual data that you're worried about. I mean, also the files can be in completely different formats. For example, this thing of cherry preserves, which is the best way to make peanut butter and jelly sandwiches, let me tell you. You just open it up, and there we go. I can access the data directly. However, how I access the data in this file is different. It is not correct, although I can do it, to open the top and access the data that way. The correct way of accessing this data is to pop the top and squeeze. That's how I access this data. For example, this could represent binary file access versus text file access. Still data, I still have to open the files to be able to access the data, but the manner in which I access that data is different. I cannot access them the same. All right, so we have figured out all of our data formats. We know, which one we're going to be using, which, by the way, those out of the way, these two. So we have all of our file information. Now we need to start opening our files. So I am going to open up the bread file and get some data out of here. There we go. Store the data in the variable that I have prepared for it. Just shove that off to the side. Access my peanut butter file. Toss that lid over there. Access the data. Again, sort of variables or different functions, used to manipulate the data. And I'll also need jelly. So let's just go ahead and open up the jelly. Got everything ready. Oh no! Something's happened. Okay. Can't block the shot that much, sweetheart. Oh no! Something's happened. There's a cat on the table. The cat is gone. Or more specifically, I need to go deal with the cat and give her a treat to make up for the fact that I just woke her up for this bit. Yeah, this bit's intentional. Okay, what on earth am I trying to indicate here with all of this nonsense? Well, something happened. The program, unexpectedly had to leave, aka shut down. But everything's still open. This file is still open. This file is still open. This file is still open. Is this a problem? Well, yeah. I mean, probably not for the peanut butter. I mean, this stuff isn't quite as indestructible as Twinkies, but probably the worst that's going to happen is it'll dry out a tiny bit. It'll be fine. It'll take weeks probably for that to go bad if I leave it open. The rest of the stuff, not quite so much. So the jelly won't go bad super fast, but it will spoil if I leave it open and just out for an extended period of time. The bread, though, this will go stale fast. Like, especially if it's like really humid out, the bread can go bad really quick. And so it's really important that this file gets closed. And this is true for programming as well. Soon as you open a file and you are done accessing the data inside the file, you should immediately close that file back up, because you never know when your program could unexpectedly terminate. So it's very important that as soon as I'm done with the file, I close it. So like, I haven't legitimately gotten the jelly yet, so as an example, it's now time in the process for me to access the jelly. So I'm going to access this file, access the data, get what data out that I need. I like squishy sandwiches. Also, I suppose a good example of why you always want to initialize your variables. This is now a dirty variable. And if I don't initialize, aka clean it, and I'd say try to use it to access this, or better yet, if I take the knife, use it to manipulate the cherry data, and then decide that I want to go back to access the peanut butter data, yeah, I better reinitialize this variable. So good side example of why you want to be careful with stale data in your variables. But as soon as I was done accessing the cherry data, close the file. That way, if something unexpected happens and the program terminates, I'm fine. Now, there's always that small degree of risk of something completely and utterly beyond your control as a programmer or beyond the control of the user can happen. Power can go out unexpectedly right in the middle of file access. That's bad, generally speaking. There are ways to mitigate that. It goes a little bit beyond this particular talking point. But just be aware that yes, catastrophic events, there we go, I can't speak, can cause data loss. But as long as you are following best practices, closing your files as soon as you are done accessing them, you're going to greatly minimize the risk of anything going wrong with your files. So let's recap. First, your program needs to be aware of where it is. What is your program's path? You also need to be aware of where your data is. What is your data's path? And if your data is not in the same location as your program, you will need to include that path information, or you will get a file not found error when you try to open your files. Upon opening a file, you want to access what data you need to access from it, whether it be read or write. And then as soon as you are done with that, you want to close the file to make sure that nothing bad happens to it if the program has to unexpectedly terminate. And again, all of this applies to any language that's going to allow you to manipulate files. Now, every language is going to have its own little idiosyncrasies on how you open files, what do you need to specify, how do you close them, etc., etc. But the general ideas here will work for any language that lets you manipulate files. So good luck with whatever project you have to do, and I will catch you on the next video.